What are the top problems in the injection molding business? Can science help you make good parts after the part design is done and cut in steel? In this video I will start with the science because the questions are complicated, and the answers are simple. Traditional molding versus scientific molding? In the traditional method of injection molding, the mold is filled with a single shot under a constant pressure to pack the cavity. In scientific molding, the cavity is filled to around 90 to 97% at a certain velocity. In the next phase, the machine switches from speed control to pressure control, where the cavity is filled or packed out to complete the process. The scientific method allows for greater shot-to-shot consistency and improved control over the specifications of the part. Conversely, large variations in part dimensions are often the case cycle to cycle with the traditional method of injection molding. A scientific injection molding approach is most essential in the production of complex parts and components where even the smallest variation in molding variables can have a remarkable impact on the process or finished product. That said, the goal of scientific injection molding incorporates two key strategies: develop a process that produces repeatable results with minimal variation, optimize dimensional or mechanical characteristics of a molded part. These are 5 critical factors that contribute to the part quality. 1. Part design. 2. Material. 3. Machine. 4. Process. 5. Mold. Steps in the scientific molding process. The physical laws that apply to plastics are precisely controlled with respect to heat, pressure, flow, and cooling under the watchful eye of specialty trained engineers. Initial shot. The cavity is filled to about 98% of its capacity with velocity, speed, control, fill and pack. The remainder of the cavity is filled, and the cavity is compressed or packed out under constant pressure, pressure control, cool and stabilize. The part cools and becomes stable before it is ejected, and the next metered shot occurs. These decoupled steps in the scientific molding process are said to allow better control of part dimensions and more cycle-to-cycle, commonly called shot-to-shot in the industry, consistency. What is decoupled 2 and decoupled 3 molding? A decoupled 2 process suggests filling to position, then joins the packing and holding phases together, utilizing second stage pressure to pack out the mold and hold until gate seal. Decoupled 3 is a process of filling to a position, utilizing a second stage of fill or machine packing to pack the mold to a set cavity pressure, and then holding over time until gate seal is achieved. Where does design for manufacturing fit into the scientific molding process? Design for manufacturing is the number one consideration for the scientific molding. If the part is not correctly designed, the injection molding process science can't not fix the part design issues after the steel is cut. Material selection plays such an integral role in scientific molding? It is the number 2 consideration for scientific molding because the material behavior and physics controls the feasible dimensional results, as precision molding tools and scientific molding cannot control the material behavior 100%. Also, part shape, size, and wall thickness are a big factor for feasible dimensional results. Plastic residence time vs scientific molding? If plastic residence time is too long, the scientific molding process cannot fix the part quality defects. Long residence time results in mechanical and structure weakness in molded parts, produced color variation, inconsistent dimensional results, and failing production. Degradation not visible to the eye is an overall compromised product. It can impact the injection molding press performance, resulting in inconsistency in the melt quality and shot weight, as well as the melt temperature. If you're using less than 25% of the barrel capacity, the material's residence time will be too long, and you'll likely see resin or color degradation during production. If you go over 75% shot size, you can expect trouble. Use 25% to 65% of the barrel capacity for your shot size. So pay attention to the percentage of your barrel capacity your jobs are using. It may be one of those molding details that gets overlooked, but it could be stealing a chunk of your profits, and it is the base for unhappy customers in the injection molding business. Scientific molding process versus the right injection molding press. Regardless of the advanced science and engineering, we must use the right tool for the job. For example, if the job is a precision molding, don't use an injection molding press designed for commercial molding. Know the injection molding machine and its capability. Make sure the injection molding machine is built for precision molding. If the molding project is thin wall product, make sure the injection molding press is built for thin wall injection molding process. If my only tool is a hammer, then every problem is a nail. Scientific molding process versus man? It is essential to have good tools, but it is also essential that the tools should be used in the right way. The followings will help you with your injection molding tryouts. How do you qualify a steel mold? What steps should you take? 4 tryouts minimum. Tryout number 1 or T0 must produce 50 good shots, followed by a tuning loop. Number 1, the tool engineer and the quality engineer will mark the molded parts defects and provide it to the tool maker, with open issues Excel files with pictures of the defects and the dimensional report. The supplier must provide a short shot study, actual parts required % full, 25% full, 75% full, 95% full. Tryout number 2 must produce 50 good shots, followed by a tuning loop. Number 2, the tool engineer, the quality engineer and the customer OEM engineer will mark the molded parts defects with fit and function report and provide it to the tool maker, with open issues Excel files with pictures of the defects and dimensional report. Tryout number 3 can include engineering changes and or the final tuning for better fit and function. Tryout number 4, stress run. This includes 500 shots followed by 4 to 8 hour stress dry run. For all the above, we must follow the scientific design of experiments, DOE. Scientific molding is a process whereby the fill, pack, and hold stages are treated separately to minimize fluctuations while improving overall product consistency. Rule of thumb for all tryouts. Make sure the plastic resin is purchased from the customer-approved supplier. Make sure the plastic resin handled for the tryout as required by the plastic resin manufacturer. For example, drying time and moisture levels are okay, and use the required dryer for the material. Make sure the molding press tonnage and shot size versus barrel capacity are suitable for the tool. For example, the shot size must be 25% to 65% of the press barrel capacity. Make sure the tool starts up and shut down are followed as required. Make sure the water lines are connected correctly in and out and no jumpers. Make sure there is no contamination from the previous tryouts. Know the injection molding press capabilities, for example, precision molding versus commercial molding. Know the plastic resin capabilities for the required dimensions, as warpage, part size, and shape can be a big issue as there is no tool design can fix the material behavior. Also, glass-filled materials can add to the dimensional inaccuracy. Make sure the molding process parameters are within the material manufacturer required parameters. Make sure the molding cycle time is within the quoted cycle time. Make sure the part and shot weights are within the quoted parameters. Make sure the fill system is designed as required by the material supplier, as some material will make much better parts with hot runners instead of cold runners. Make sure the venting system is open and designed to vent all deep pockets. Make sure the tool steel cavities and cores, part 3D data and the 2D drawing are matching. Make sure that you have provided to the tool builder the required shrink factor for the tool construction. Use the general scientific fill requirement for design of experiments. Make sure everyone involved in the tryout knows how to operate the mold, especially if the mold has crash conditions with limit switches, or if the mold is 3-plate mold with requirements for sequential open and close, and pay attention if the mold is built with hot runners, as hot runners can drool in the tool and damage the mold. Know the mold design and the steel used for the mold construction. Know the 2D drawing and the production plant capabilities for the production and the mold maintenance. What is flash? It is a leak in the mold parting line, most likely caused by excessive gas and pressure in the mold cavities, or maybe the tool needs a bigger press and or the mold parting line needs maintenance. Mold spotting. How do you eliminate flash? Use the short shot study and the design of experiments and the injection molding scientific process for troubleshooting the issue and fix as required. In a nutshell, if the molding parameters are within the required range and the mold is balanced but still the mold produces parts with flash when molding short shots, the mold must be spotted. I don't recommend welding for a new mold, especially welding a parting line. However, if all fails and you are sure that the tool does not need a bigger press and only if the parting line is damaged and the tool requires spotting, welding can be the last option for the fix only if all involved approved welding the mold. This can be determined by the design of experiments process and the short shot study. Now I know that you can answer the 2 questions I have asked on the first slide of this video. My name is Amer Janineh. Thank you for your time.